Anyway, so on now to the first session. So we're now thinking about pharmacovigilance and pharmacoepidemiology. So I'm going to start by telling you some of the history that's led to modern day pharmacovigilance. We'll talk about spontaneous reporting, what this is, how it's used, and the strengths and weaknesses. We won't be talking about history leading to modern epidemiology, that's wrong. We will then talk about pharmacoepidemiology and how it fits with pharmacovigilance and a few examples. We'll talk about the need for risk management planning and how this is done worldwide in order to make sure our medicines are as safe as possible. And I'll also talk about what I see as some of the main challenges to us as people doing EHR research in this area. Okay. This was something that happened in the early 1960s, and it was probably the biggest trigger for modern day pharmacovigilance. Does everybody know what this picture represents, this photograph? Any ideas what this is?
A newborn baby who is harmed by, because his mother took the drugs suddenly.
Yes, that's right. Yeah. So this is the thalidomide disaster from the early 1960s. At this stage, there was no formal process for monitoring the safety of medicines. Okay. So what happened was a doctor from Australia called Dr. McBride wrote to the journal The Lancet, and he had made some interesting observations. He knew that birth defects were relatively uncommon, and he thought that they happened in around 1.5% of babies normally. But he found that over a short period of time that he'd observed many more cases of birth defects than you would expect, and that they happened to women who'd been given thalidomide during pregnancy. And he went on to describe a pattern in these birth defects. Now at the time, as I say, this was the only way people could raise awareness of this kind of problem in a, there was no other way of doing this. There were no regulatory authorities that you could get involved. You had to do this kind of thing. And this is why thalidomide was such a disaster. We could spend the whole of the afternoon talking about thalidomide, and there are books written on the subject which are very, if you're interested in drug safety, a very interesting read about the various steps that went wrong during the process of thalidomide becoming available. It was probably one of the biggest tragedies in modern medicine, and people have tried to estimate how many people were affected worldwide by this disaster, and the estimate is somewhere between 10 and 20,000 babies who were born with birth defects due to thalidomide. In fact, we think that this is only the tip of the iceberg, because the effects of thalidomide were so severe that in many instances they led to fetuses that would have died before they were born because the defects were so severe. So in fact, 10 to 20,000 is probably a very major underestimate. Way more people were affected than that. At the time, the expectations for clinical testing were much lower, and the expectations for animal studies were much lower. So the number of species that you have to test a drug on was lower. And then there was no formal method for screening for adverse events once a drug was launched. So at the time a drug is licensed, even now, even with our very precise way of measuring the safety of medicine during development, we still have very limited information on the potential harms of treatments. I would say that we also tend to have incomplete information on the expected benefits of a treatment. So animal testing is much improved. We now have to test on more than one species, and we know now much more about how to interpret these results, how to do the testing to try to preempt the problems of thalidomide. Randomised trials are obviously conducted before a drug can be licensed. Any ideas how many people, or a guess at how many people will have been exposed to a new drug by the time it's given a license? Any thoughts?
Up to a few thousand.
Yeah, a few thousand, okay. That's at best. Okay. And this is probably the most common, but certainly for some of the treatments for rarer diseases, it will be even fewer, a lower number. So the problem is only a small number of people have been exposed, and the types of people exposed will not be representative of the types of people that will receive the treatment in routine care. So we will often exclude the elderly, children, pregnant women, people who've got liver or kidney problems, and people that take lots of different medications or who have several illnesses. Now, that to me sounds like exactly the people that we will then treat with the medication. But in fact, we leave them out of the randomised trials for good reasons, because we want to do our best to estimate the ideal benefit of the treatment under controlled conditions. But it means that at the point of licensing, we're missing information on all of these kinds of people. It's very unusual that we would have experience of treating people for a long period of time when the drug is licensed. So if you imagine a treatment for type 2 diabetes, we may expect people to take this for 10, 20 more years. We have no idea what will be the long-term consequences of taking the treatment for a long period. So we also may have got the wrong dose. Remember, if you are working in a drug company, then some point during phase 1 and 2, you have to decide which is the best dose for the treatment. And this will be based on several considerations. You will want to be able to have the best chance of demonstrating a good effect, a good beneficial effect. And sometimes this means that we may have selected a dose that is higher than we really need. And it may only be some years later that we find out what in fact would be the ideal dose. So at the point of licensing, we've demonstrated efficacy, and this is the ideal effect under controlled conditions. But we know nothing about effectiveness, which we'll come back to later on, but which is in fact what happens when we give the treatment in routine care, and it can be quite different to efficacy. Okay, so there are limitations at the point of licensing which we need to try to do something to address. Which brings us to pharmacovigilance. So I've put up a definition here which I quite like. It's quite an old one, but I think it describes what we do in pharmacovigilance. So it's the science and activities relating to the detection, evaluation, understanding and prevention of adverse drug reactions or any other problems to do with the treatment. Okay? I would say this is a very broad field, and that the evidence that we consider for pharmacovigilance can come from any source. Sometimes in the United States, pharmacovigilance has been considered to be only to do with spontaneous reports, but we think it's actually much broader than this, and that we can get evidence from any source.